So my name is Mark DeLaVergne, and I'm excited to talk through a wearables data feed that we built at LifeOmic. And I'm kind of going in speaker view here, so just you can pay attention to this area of the screen, and you can kind of see what's up ahead too. I've been in Indianapolis doing software engineering for 10 years. I joined LifeOmic in 2017, and I'm on the Precision Health Cloud team. LifeOmic has a really empowering culture. You can really take an idea and be able to run with it pretty quickly. And, if we've got too much on our plate to start up right away, you kind of queue it up for a hackathon. We have 2 or 3 per year, and it gives us an opportunity to, we're typically like at a retreat for a day or two, and you just kind of do 24 hours of hacking on a pet project and trying to, let me see if, okay, here we go. Okay. Flesh something out. So a little context going into this, we have 2 mobile apps. The first is Life Fasting Tracker, and that allows people to try out intermittent fasting. We've had 1.5 million downloads. That's growing every day. I'm sure that's out of date by now. We also have the Life Extend app, and this is all about giving the user 5 pillars to strive for every day. And the idea is if you max these out every day, you will significantly improve your health. So that's eating plants, 30 minutes of exercise, 20 minutes of mindful moments, 7 hours of sleep, and intermittent fasting. And that's got 250,000 downloads. I'm sure that's out of date too. And so I was on a little bit of a weight loss journey. I really have been over the past 5 years. And this is the first year that I think that I've finally kind of made the lifestyle change to make it last. And what really makes me tick and allows me to, I think, really make the change this time is to see my data. And as you can see, I weigh myself every single day. And during that process, early in 2019, it just really dawned on me how much data is on my phone in Apple Health Kit. Apple Health Kit is really awesome because apps actually write to it. There's a lot of on-device data hubs or, in the cloud data hubs that there's just not enough integration with. But in the iOS ecosystem in particular, if you make a jogging app or something like that, and your competitor writes to Apple Health Kit and you don't, they've got the leg up on you. So that's they've just created a pretty cool environment there that gets a lot of data onto your phone and able to be shared with platforms like LifeOmic's. So I've got here in my notes like activity, body measurements, mindful moments, some macronutrition, sleep, vitals like heart rate and respiratory rate and blood glucose. And then again, you kind of multiply that by the number of users we have. And I just got to thinking, hey, the time is now. We have an amazing mobile team at LifeOmic, and we had sort of the wearables integration in the backlog. And again, just with the empowering culture here, I kind of pitched this to a few people for a hackathon, and we knocked it out, and we synced like 75,000 health kit records from my phone and sort of showed it in our platform. And then after that, I pitched it to the CEO and a few others, and we were kind of off to a races. So one last piece of context before we get into sort of the architecture we built out. And that is, this architecture is something that we built out in early 2019, whereas the hackathon was, I think, May or June, and then we officially started like July or August on the health kit integration. So this is an early architecture built for an HTTP-based EMR. And I'll just walk through this diagram here a little bit. So this symbol is for Lambda, the AWS Lambdas, which are sort of functions in the cloud. And there's an API gateway in front of this. And so the EMR would send HTTP notifications and invoke our Lambda here. And then we would store little bits of information on what patients and attributes need to be synced. And then on a nightly basis, we use CloudWatch events to sort of schedule an invocation of an EHR ingestion Lambda. And this, when invoked for the evening, would read the sort of pending updates and enqueue them into an SQS queue. And then we had another Lambda for EHR record ingestion, which had its event source as the SQS queue. And so for each of those patient deltas, we would then ingest it into our FHIR database. And we use Aurora MySQL, and we have sort of a Lambda that handles the bundle upload. This Dynamo table isn't too important, but it's basically just a mapping between, the EMR's patient ID is ABC, and then our patient ID is going to be a UUID. And so that next time we ingest that patient, we can just upsert the record. So we created, even early in 2019, sort of an ingestion recipe for EHR. And from the get-go, we use the term EHR pretty loose for electronic health record, where in code anyway, we use EMR as sort of the electronic medical record like Epic or Cerner or some of these others. Whereas, EHR in our code is just sort of referencing any sort of data source that can provide health data. And we created this recipe for if needed, you'd have the Webhook ingestion Lambda that you could consume. And these are just the TypeScript methods on the right here. The next Lambda is the EHR ingestion. And the two methods there are prepare for ingestion, where you might need to download some data or somehow transform it if needed. And then start ingestion is where you'd basically enqueue it into SQS. And then the EHR record ingestion is where at an individual record level, so for example, a single patient, we would prepare would be if we needed to download any additional data for that particular patient, transform the proprietary JSON to FHIR, which is what our database understands, and then upload it as a FHIR bundle. So walking through that recipe, two examples, and we'll start with the HTTP-based EMR. Again, the webhook would basically be handling those notifications that patients need to be synced and store that in Dynamo. The ingestion Lambda would actually download the patients as needed, and then enqueue that as an SQS message. And then the EHR record ingestion would fetch the individual patient's data, transform it, and ingest it. And last summer, as we were looking at whether we could reuse this, it became clear we sure, it should work out pretty well, where a completely different use case, but within the same Lambda, the webhook ingestion is actually a batch of health kit records that's coming from the user's device. The EHR ingestion can simply in-queue the records right away. There's nothing to do that we need to do there. And then the EHR record ingestion can transform each of those records and ingest as FHIR. So this is how we built out the Apple Health ingestion. And again, instead of the EMR hitting our webhook ingestion Lambda, it's actually the user's device. HealthKit is a true client-side hub of data. So like there's no, synchronization behind the scenes or anything. Like the data actually lives on your phone. And so we built a native HealthKit integration into our two apps, and given the user's permissions, we can pull records like sleep and activity and ingest it into our platform. And so that's sending across HTTP to our webhook ingestion. And then in this case, we actually didn't enqueue it in SQS. We went straight from the EHR ingestion record, Lambda to EHR record ingestion. And primarily we did that for speed. We just didn't need the SQS queue, and it added some latency, so we just skipped it. Another flow that, as we started to build out Fitbit and Aura and some others, is where the user goes through an OAuth process or an OAuth flow where, from our app, they're presented the Fitbit login screen. They log in and then they authorize LifeOmic to be able to access their Fitbit data. And we then create another scheduled event that will invoke our EHR ingestion. But in this case, we simply query for all the users that are enabled for that wearable and enqueue each of them in SQS. And then the EHR record ingestion actually downloads the data given their access token, and then transforms and adjusts it. And this is really the main other model that we've used, where the wearable supports a subscription model. So during that OAuth flow, we sort of subscribe to the subscription of the user's data, and the vendor is actually sending us batches of data, or a lot of times it's actually notifications to then download downstream. And so this is the case with Garmin and actually Fitbit as well. This is a little more real time, as you can imagine, than the previous model, because as soon as the data is available within the vendor's cloud, then it's sent to our webhook. And so we can ingest it immediately and it shows up in our apps. Whereas with the scheduled model, say we're doing every 15 minutes or an hour, there's sort of a little delay there. But when the vendor doesn't have the API, you work with what you have. So that's some of the initial architecture and models that we used in AWS. And now I want to walk through some of the more important decisions that we made that I think turned out really well. We walked through some of those webhook payloads that the Lambda, the webhook ingestion Lambda is invoked with. The first one was the EMR, where we're receiving notifications of patients needing to be synced. The second was Apple HealthKit records that need to be ingested immediately. And then the third was where we have a subscription model for the wearable, where they're actually sending us batches of new records or notifications to download records. And, this is all happening in the same Lambda. And you might imagine some sort of type on how we're determining, which code to use. But if you think about the first and third examples here, we don't control the payload. And so, you know, you could sort of create a Lambda per, but that's going to struggle over time as you grow. And so the way that we did this is that when we configure the webhook for the vendor to call or the EMR to call, it always has the context of an EHR ID. And so when a request comes in, we'll fetch that EHR configuration that was provisioned beforehand, validate it, and then that sort of determines which TypeScript class or, you know, path to take on how to ingest this. So this was a big topic of conversation early on as we got started on HealthKit, and has always been a topic for us of how do you keep from getting duplicate data, or do you just embrace it? So each FHIR resource, which is just sort of the record in our MySQL database, is ingested with one or more codes, such as SNOMED, and our mobile apps query the FHIR data based on codes. So just unpack that a little bit. So when you allow HealthKit to sync, we'll ingest that with a SNOMED code, system and value, that indicates that this is a record that represents the person slept for this duration. And all of the wearables need to store the data in that way. And so if you think about, if you have your Apple Health data storing your sleep data, and it says 7 hours, but you're also wearing an Aura ring or another wearable that also stores the same sleep, how do you keep from sort of duplicating that? And we made the decision to allow one wearable integration at a time. It's basically just like a garbage in, garbage out decision of, we really want to clean everything up before it's ingested. And so on this front, we don't do any server-side data deduplication or anything like that. We really just ingest the records that are clean from the beginning. And I put here soon to be one per type. So one thing that we have on the books is to be able to say, I want HealthKit to sync my activities, but I want my Aura ring to sync my sleep. But that still keeps the cleanup of the data before the ingestion. And this really comes into play with HealthKit from the beginning, because they have sort of two data types for sleep. I keep on using sleep as the example, because it does tend to be the more complicated type for some reason. But in HealthKit, they have sort of in bed. So you might have been in bed for 8 hours, and then actual sleep, you've been sleeping for 7.5 hours. And so you have to decide right up front before you even ingest the data, are you going to attempt to, take the better? Are you going to just take one? If you choose sleep, some apps only write in bed. So if you just sort of hard code sleep, then you'll get nothing. So those kinds of decisions, we've really taken this approach of just cleaning up the data before it goes in. And it's worked out really, really well. So it's pretty easy to spin up a few microservices in AWS and get something like this working. But I want to walk through some of the challenges we hit and the way that we work through them. The first is, this is actually coming back to that HTTP-based EMR, where the EHR record ingestion is actually downloading the data from the EMR, and it's an on-premise web server in this case. And what we basically ran into was with SQS, you know, you're going to have multiple Lambdas invoked at a given time. And this is something that you have to really watch out for when you set up Lambda as an event source, or SQS as an event source for Lambda, is just concurrency control. You know, it's set up nicely for if you need to process a lot of things somewhat in parallel. But in this case, we really wanted to do a few at a time. We thought 10 at a time would be fine. And there are a lot of SQS settings that you can play with, like first in, first out. So by default, SQS is actually sort of, you know, they're going to try to kind of put it in order, but it's mostly going to be, you know, you're going to have them out of order. And it's also going to sort of not wait for one Lambda to finish before another one's called. So automatically you can get out of order there. And then some basic sort of delays and timeouts that you can apply to how the SQS poller that's built into Lambda service, how often it's going to invoke your Lambda. And then on the Lambda side, you have a couple settings like batch size. So that'd be like, do you want 10 SQS messages to invoke to be sent to your Lambda invocation, or, you know, 20? And then the one that's you really have to watch out for is reserved concurrency limit. So that's basically saying that the Lambda can only be invoked, you know, this limit at a time. And you can pretty easily get into a scenario where valid messages are throttled enough times that they actually go straight to the dead letter queue before even getting to your code. The way that can happen is, say you've got a reserved concurrency limit of 10 and a burst of SQS messages come through very quickly. And let's say that your Lambda takes a little time to complete its tasks. Well, you can imagine one record getting throttled 4 times before 10 concurrent Lambdas are completed. And then that message goes to the dead letter queue. So those are some challenges we ran into. And most importantly, it really didn't provide the level of timing control we needed. We found that even when we sort of kept on playing with these settings and getting it to where we wanted, it was really still too much for the on-premise web server. And so we really needed the ability to just run one at a time. And even running serial like that, it was going to be too much. And so the solution in this case we went with was an ECS batch job. So, you know, this is like a spot instance of an EC2 instance where you can, you know, run some code and have some, in our case, we wanted some intelligence to potentially even delay between records to make sure that the EMR web server could catch up. So the next challenge, kind of an interesting one, was a race condition where we've got overlapping records from a single vendor, from a single wearable, let's say Garmin. And so there's 2 sleep records for whatever reason coming in for the same user. And one is for 7 hours and one is for 7.5 hours. What happens a lot of times is that wearable devices sort of think of the phone as also a device. And, you know, you can also have 2 devices on, you know, it can get pretty crazy. But even in the basic case, a lot of times you have overlapping records like this. And so the way that we handled that is downstream. So we received the batch of records. There are 2 overlapping. And within EHR ingestion, we actually determine which one is best. They've got some types, and so we kind of have some rules in there, and then also like duration, you know. So we sort of determine which one is best and ingest that one. So again, clean up the data before it comes in. But now imagine that two webhook calls that are at different times have overlapping sleep records. So what happens is we'll get a webhook notification at 3 a.m. or something like that as some partial amount of sleep. And then when the person wakes up and syncs their data, another notification comes through for a greater time. And so in that case, it's important that we have to query our FHIR API to see, is there an existing sleep record that overlaps with the one that we're trying to ingest right now? So that's how we handled that. But the last tricky thing here is that we have an eventually consistent API. There's a kinesis stream and there's Dynamo involvement. And so what can happen is if two records with overlapping, if two ingestions come in with overlapping records, they go through all this process and they query the FHIR API. Both of them see there are no overlapping records and both of them get ingested. So the answer with this one was switching to a kinesis stream. While with SQS, by default, if 100, SQS messages come in, it's going to try to invoke Lambdas like up to 100 times, depending on how long it takes. With kinesis, particularly with one shard, you're going to be called one at a time until the Lambda completes. And so if you think about, even if these are called at the same time, if it goes into the kinesis stream, one will be handled by EHR record ingestion. We'll query the FHIR API, no records. We'll save to the FHIR API. We'll then verify that that record is there, sort of eliminating the eventual consistency before we sort of return from the Lambda. And then the next record comes in and we can then discover that there's another sleep record there. So after some of those enhancements, this is what the architecture, this is a really simplified view, of course, but the dotted lines sort of represent the optional paths that a wearable ingestion might take, or our HTTP-based EMR. So again, you can optionally use a webhook ingestion. You can optionally schedule ingestions like an hourly sync. If you have a lot of data that can just be processed via Lambdas in parallel, you can enqueue SQS messages. If you want to send all of them through one shard and process them one at a time, we have the kinesis stream. And then for the scenarios where we need a lot more control over the record timing, and also if this just involves a job that is going to go over 15 minutes, which is the limit for a Lambda function, this would be another case for our ECS batch job path. And I just put these in here to note that we're sharing code via NPM module here and containerizing that for the ECS batch job. And so these are our current offerings. BioSense is really cool. It's a device that allows you to breathe in and get a breath ketone measurement. So probably everyone's aware of like blood ketones, where you can prick your finger and see how your body's doing with ketones. But this is a much simpler, no prick, just breathe into this device and you get a measurement, and you can do it more often, and it's pretty cool. And then Aura is an amazing device that is, I think, really the leader on sleep tracking. Just incredible accuracy and depth of data. And of course, these are obvious. And we've got more coming on the way: Samsung Health, Google Fit, MyFitnessPal. We've hit kind of a sweet spot where, again, sort of reusing that architecture we can spin up these pretty quickly. So I've got a few more slides here. I didn't show all the Lambdas that are involved here. We have a very event-driven architecture at LifeOmic. As you kind of saw, Lambda and DynamoDB are sort of the first go-tos, and so we have almost 20 million invocations per month. Some of that is like if a user is deleted, then we have a Lambda that's invoked off of a Kinesis stream to detect, oh, this user is deleted, we need to delete their wearable state. That's a lot more than what I really showed in some of the diagrams, but I thought I would go kind of high on the Lambda side. And then Dynamo, not too much data stored here, just maybe 3 GB of index storage. And then SQS, around 1.5 million requests per month. Requests would be like to all three, to publish a message, to receive it, and to delete it. That's how the costs work out. So that's what I'm leading up to here. And for Kinesis, just 1 shard, less than 10 million puts of 100 kilobytes per month. And S3, we just use 1 bucket for some temporary files. So this is really an inversion of our typical cost pattern at LifeOmic, because as you use Dynamo and you store some real data there, it can grow. Whereas Lambda is, we use it extensively. We're very, very serverless, and so usually Lambda is really low. But again, I sort of went high on the Lambda guesses, and but this is all very, take it with a grain of salt. But I think the real point here is how cheap this all is per month with the amount of data that we're pulling in. And last slide here, I just wanted to touch on the way that we monitor these microservices and so forth. And I see I'm pretty early on time, so I'm actually, before monitoring, I just want to touch on our continuous integration process. We have unit tests, service tests, validation tests, and then this monitoring would be the end-to-end test. And all those non-monitoring tests are running on every build. We ship artifacts through our environment. We have a pretty awesome DevOps flow. But as far as these Lambdas, we have an integration with PagerDuty off of the CloudWatch metrics, and you can create CloudWatch alarms off of metrics, like a Lambda invocation just had an error, or it ran for this duration. If it's over 2 seconds, then let me know. And then Kinesis iterator age would be like how long before the Lambda is receiving events. As that grows, that means you're getting behind the stream, and that can be a big warning of something going wrong. So when one of these alarms goes off, we get a page from PagerDuty. It's pretty awesome, and allows us to quickly respond to it. And then again, on the end-to-end tests, one pattern we formed is to create a Lambda that actually does sort of a full pass of a given API or something. And so we have Lambdas, like, for example, that will do a full sleep record ingestion of a health kit data, a health kit record for like a test user every 15 minutes. And so that's just really comforting to know that even after all the layers of tests, if a regression never slips through, we'll know really quickly based on that. So I went a little fast. I was going to try not to, but thank you so much for listening. That's all I have. So that's my Twitter handle there, but